Okay, everybody, we are going to learn about inverse functions, okay? So I need you with me. The first thing we have to do is hit the definition of an inverse function. And let's hit that right here, okay? I don't know if this is going to be part one, part two. I don't know what this is going to be, so we're just going to let this go and say inverse functions. Two functions. Let's just call them f and g are inverses of each other. If, and only if, but I'll just say if, two things happen. So I have two bullets. The first bullet is that f of g of x has to bring you back to x. And the second bullet is that g of, take a guess.
G of f.
F of x also has to bring you back to
X.
x. So let's think about what we're doing for a minute, and I'm going to actually pull a lot of information out of you guys for a moment. I am going to pick a mapping over here, and I'm going to, how about if I just tell you f of x on this one, as opposed to giving you some points and having you come up with the function. I'm going to give you a function, f of x equals 3/2 x minus 6. And I want you to give me some points that belong on f of x. So give me some input, output values.
9.
Say it again.
4. 0 and negative 6.
0 and negative 6 works. Yeah, think about that. You put a 0 in for x, right? These are your x's or your input to the function of f. And these are your outputs or your y's. Okay. This over here is known as my domain of what? Of f. And over here this is known as my what?
Range.
Range of f. I'm going to write of f of x, okay? The only reason I'm writing f of x instead of f is because I don't want you to think I'm saying range off, you know, domain off, range off. No, that's not, okay? All right, so 0 goes to what? Negative 6. Put a 0 in for your x, and this term will basically go to 0, and then minus 6 to negative 6. Give me another one. Think smart. Pick friendly numbers.
4.
4 what?
0.
Yes, good job. 4, 0. Okay, we put 4 in here. That's 3/2. I can come over here and just write f of x equals 3/2 of my input and then minus 6. And I can change my input to anything I want. So I'm going to change my input to a 4, which means the 4 is here. 4 is really 4 over 1. So this gives me 12 over 2, which is 6 minus 6 is 0. Okay. Now I'm going to keep switching this number here, though. Give me another input.
2.
2. 2 is an easy input, isn't it? Why is that easy? Yeah, the multiplication and division by 2 cancel out, and you're left with what answer? Negative 3. Did you say negative 3, I hope?
Yeah.
Okay. Give me another number. What other number you want to put in there?
6.
Can you throw a negative in there for me, please? We got a 0 and a 2 and a 4. Want to do negative 6? So I want to put a negative 6 as my input this time. Say it again. I guess I'm just not hearing it.
You said negative 15.
Negative 15 is right. Okay, I doubt highly I'm going to sketch that one. You okay with that? Yeah, hopefully. Negative 9 minus 6, negative 15. All right, so notice that the values that you picked were nice, pretty numbers. They were nice in what? What were these numbers?
Whole.
They were whole numbers, but more than, well, they're whole, they're integers, because we got that as negative on here. Whole is 0, 1, 2, 3, 4, 5.
Yes.
Okay, integers have positive and negative whole numbers. Okay, but they're all what? What good word describes them?
Number even.
They're all even. Okay, which made the division by 2 real nice, which meant you picked some nice friendly numbers. Okay, what I'm looking for is a function that's going to undo everything that f does to any input. I want it to actually go backwards and take my output and bring me back to my input, which is what we call an inverse function. I'm going to graph this. While you guys are kind of thinking about that for a minute, I'm going to put an XY graph over here and plot those few points. But, actually, I'll just go here. And I'm looking at what, 0, -6. What else? 4, 0. Well, it's important that your scales are consistent. 2, -3. So far, it's looking pretty good, eh?
Yes, ma'am.
What else? -6, -15. I don't wanna do that one. What else could I plug in there instead of -6, -15?
-2.
Yeah, let's do -2 or something. You guys tell me where that goes?
-9.
-9 is good. Of course, I erased my thing, but the 2's we cancel, you get -3, take away 6 makes -9. So I will sketch that one if I can. And I'll try and draw this line to the best of my ability. Yeah, she's going crazy, isn't she? Never reason. Okay. Alright, good. Anybody think of the inverse? Anybody come up with an idea? You said -2/3 x what? -6. Let's just test that, okay? I'm gonna call this g of x. Let's just test it. Let's pick an easy number. What's a real easy number to pick? 0. Are you picking this 0?
No, the Y.
We understand that we're over here now. So when we're talking about the function g, that's gonna be going backwards, that this whole set now turns into the domain of g of x. It used to be the range of f of x, it's still the range of f of x, but it's now the domain of g of x. And over here would be the
range.
range of what?
G of x.
Range of g of x. Okay, so you said pick a 0, so I'm gonna pick this 0 right here in the domain of g of x. Put a 0 in there. What's -2/3 times 0 minus 6? -6, but I want the answer to be 4. So I'm sorry, but one thing I know for a fact is that's not it. Okay, what else can I do?
Plus.
Anybody wanna give it a try? Okay, I'm gonna give you a little story about socks and shoes, which is kinda crazy, but in the morning when I get dressed, I put my socks on, then I put my shoes on. Okay, I do socks on, and then I do shoes on, and it's in that order that I do the dress of the feet in the morning, okay? And when I go home at night, and I'm getting ready to get rid of the socks and shoes, do I put my shoes on?
No.
No, because my shoes are already on. So what's the first thing I do, take my socks off?
Shoes off.
No, I have to take my shoes off first,
Right.
and then I'll get to my socks, right? And then I can take my socks off?
Yeah.
Okay, so I have to reverse this process, but I don't just do everything in reverse order, I do the opposite of what I did originally in reverse order. Yep.
6x, is it, cause you would do the 6 last, so 6x, or would be -6x?
Or 1/6.
6 over 1?
1
1 over 6,
1/6.
1 over 6.
Okay, so I love what I'm hearing, okay? But I need those operations to be reversed slightly. So let me just, instead of socks on, shoes on, tell me what we did with every single x value to go through this process to come out here to our y values.
You times it by 3 over 2.
I
then-
tell, whoa, let's
I'm
get it down.
multiplying
I
it.
said, whoa.
I was collecting my ink.
Okay, so what did you say again?
Multiplied it by 3 halves. And then subtracted by 6.
So check
So
by 6.
I take an x value, I multiply it by 3/2 and I subtract 6, and what I get is 3/2 x minus 6.
Yes.
Now I want to,
Minus 6 times
I wanna go the, yes, what'd you say?
Add 6.
I wanna add 6.
Yeah.
See, it's not the 1/6 I want, is it? Because the reverse of subtracting would be adding, very good, okay? So now the x is being taken over here, but be careful, because the x that I take for my g function is actually the y value I ended up with in my f function. We can talk in circles all day long, but that's what's true.
You said the Y and
Yep, the y value that I got when I put my domain x value through the function f becomes the x value that I'm going to use through the function g to come out here. And these will be the y values in g. These are gonna be the x values of g. So the x values of g are actually the y values of f. They're the same thing. The domain and range are gonna switch around. This was once the domain of f, the range of f, now this is the domain of g and the range of g. Okay, so what did you tell me I was gonna do with this?
plus 6.
Add 6. So I know what that looks like, that looks like x plus 6.
And divide by
Divide by
3/2.
So how do you divide by 3/2?
You would multiply by the reciprocal.
Multiply by the reciprocal, so that's multiplied by
2/3.
2/3. So then, so I have to add 6 and then multiply by 2/3. That needs to be wrapped in parentheses. So let's just test this, okay? If I take my input value and I add 6 to it, and then that whole thing, I multiply by 2/3, now we're gonna test a number, and let's test a different number, but what set am I testing it in? Am I testing it
Y
in
X.
Range of
the range here, the range of f of x or the domain of g of x? Either way, I gotta pick these numbers, right? What number you wanna pick?
0.
Oh, come on, yes.
-3.
-3, let's pick a -3. So I'm gonna put a -3 in here, and I'm gonna add 6 to it, and then I'll multiply by 2/3. What's -3 plus 6? 3. And what's 2/3 of that positive 3, you said?
2.
That's 2, and am I supposed to get 2?
Oh, we're so smart.
You are. You are, hold on, I need my sunglasses, except I don't know where they are, because you're so bright.
Oh.
Get it?
I was like, what?
Okay. So, I know what you'd like, and I would like you to do it too. There is a method that we can have that will algebraically spit that answer out at us, so we don't have to think about socks and shoes. Does that sound like a good idea?
Yeah, I like socks.
I like socks and shoes too, but we're just gonna do this. Alright, so, I'll get to that in just a minute, but, so far so good. We've got the g function here, and everything is good. Alright. Hey, I plotted these points. Is this a function?
Yeah.
Yes, it certainly is a function. This is my f of x is equal to what? 3/2 x minus 6, right?
Yes.
Okay, I want that 6 in there a little nicer. It's not quite so nice either, but the idea is there, right? No, can't do it. Okay, so 3/2 x minus 6. Let's plot the function for g. What do you got?
Oh, I was gonna ask, at the end, would you square your graph, or would you do like 3 dots to show that you proved it? I was just trying to figure out how would you, I didn't finish that, but I was wondering how you go about it once you find, I was wondering.
Well, if I tell you to graph it, and graphing is part of your answer, then you have to box a graph. But whatever the directions are, really, I haven't given you any directions, I just kinda like talking about what all this stuff is. Okay, so we have this function f, and we have this function g, and what I wanna do now, and all I know it's like, I picked the -3 and I went through and I got a 2 out of the deal, that really doesn't prove anything to me. I wanna literally verify that f and g are inverse functions. So I have to do these two things right here, and this is what I wanna do with you right now. Alright, it's gonna come down here. I'm gonna say, show that f of g of x equals x. That's what's gonna happen right in this spot. So I'm gonna start off with f of g of x. And by the time I'm done, I hope the whole thing equals x. Good? So this is a colon, this is what I'm doing. Alright, so f of g of x, what does that mean?
You have to do g of x, get that answer, and then you multiply by it.
You you gotta take that g of x and insert it inside f of x, right? And I'm gonna use those two as examples over here. We're gonna verify that those two are indeed inverse functions of each other. So this is f of, now what's g of x? 2/3 x plus 6. And I'm gonna put big parentheses around something and little parentheses around something so you can distinguish what pairs up. Okay, so far so good. Now the function f takes whatever your input is, multiplies it by 3/2 and subtracts 6. So I'm gonna set that up. It's gonna be 3/2 times my input and then subtract 6. Don't I do that over and over again?
Yes.
Write those parentheses down for my input every single time. So again, the function f, which is up here, is 3/2, whatever your input is, and then minus 6. This time my input though is gonna be all of the function of g. So this whole g function, this 2/3 x plus 6, literally has to go in that set of parentheses where this x is. So I'm putting a function into the function f. So 2/3 times x plus 6. And now is where everybody in the room might do something different. But hopefully by the time we all get done, we get the same thing. So some people are gonna multiply the 3/2 times the 2/3 and make them go away, become a 1. Other people are gonna look inside these parentheses and they're gonna distribute the 2/3 to the x plus 6. I don't really know, what do you wanna do?
The first one was
Yeah,
make
so
it one.
You wanna do that first thing? Okay, well see, I gave you both options, so you're gonna pick the easiest one now, right?
Yeah.
But in reality, don't you think you probably would've multiplied through that 2/3?
I don't know what I would do.
Okay, I'm sorry I even asked you and told you
That's
which.
a logical thing I would have done.
Okay, so I'm gonna take the 3/2 and the 2/3 and they're gonna divide off, I'm gonna get 6 over 6, right, which is
One.
1. So then I just get x plus 6 minus 6, which is just what? X, and this is f of
Oh,
g of x.
that's so
sweet.
smart.
I just had to sit back.
Hello.
I've only done one piece of it now.
We have to do that.
Oh, I only did the first bullet.
You gotta do G.
I needed the g of f of x.
I like the sauce.
Which one? Hey, which one? The one here?
Oh, it's just, it's RD.
Is that what you meant?
Yeah.
Okay. I don't have to write a 1. I can write a 1 if I feel like it. But if I don't write a 1, there's an understood 1 as my leading coefficient on that x anyhow. Okay. Now, you guys hopefully all have that in your notes, right?
Yes.
And if you're watching it on the video, hopefully you've copied it down already. But I'm gonna erase this now, and I'm gonna show the other way, because I don't have room to put it in here.
I have a question.
Actually, I can squeeze it right here if I want to. Yes.
So when you got the one, wouldn't never mind, okay. So I was like, wouldn't you have the one there, but then you would have to multiply it by but since it's just one, you wouldn't.
Yeah, so you're right about that. These two fractions, when you multiply them together, get a 1, but that 1 still has to get distributed to the x plus 6, right? It's still giving you x plus 6. So it's okay. All right, and here I'm gonna show that, what?
G of f of x
G of f of x equals x. So I need to do that. So I'm gonna start. G of f of x equals g of, and what's my f of x?
3 halves x minus
3/2 x minus 6. Now the function g is right here. The function g is 2/3 times the quantity of my input plus 6. So that's 2/3 times the quantity of my input plus 6. You see that? Little parentheses embedded in the big parentheses? And what's my input gonna be to the g of x function? It's that f of x function, right? We gotta input the f of x function into the g of x function. So I need 3/2 x minus 6, right in here. 3/2 x minus 6. And that's gonna be hard to see on video, so I hope you're listening to me too. 3/2 x minus 6. Now this time, can I cancel off these 3/2?
No.
No, not now, I can't. 3 halves and 2/3. So 2/3, open parentheses. What can I do here? Anything? You see this -6 and this +6?
Not my turn.
They're opposites of each other,
Make it.
so when they go together, they spontaneously combust to nothing, right? Make 0. So now I have 3 halves x. And the +6 minus 6 is gone. Now I multiply 2/3 times 3 halves. Gives me, gives me 1. So this is just what? And what did I find? G of f of x, this is G of f of x, this is G of f of x. And these two pieces of information together, okay, I'm gonna do this down here, I'm gonna say therefore, f and g are
Equal.
what?
Inverse.
Inverses. I could say inverse functions, but don't have them on my board. So, stop, don't forget that.
Of each other.
Yep, I should say inverse functions of each other, just don't have enough room, so good. Alright, so anytime I ask you to verify or show that f and g are inverse functions of each other, this is the algebraic solution I need. Got me?
Yes.
So you said if F and G are inverse, and that's a box.
So far so good?
Yes.
Alright, well I wanna wrap it up a little bit because it's really kinda cool how everything comes to a finale over here. Okay, so, and I don't really know if I'll be able to see it, I hope I am. So I wanna graph g of x up here. Hey, by the way, sometimes instead of calling it g of x, we actually call it f inverse of x, and that would make logical sense, wouldn't it? I mean, if something is labeled as f inverse, then I don't need to ask you are they inverses, they just are. But that's why we say g, because sometimes you can test to see whether or not you're inverses. Okay, so I need some points up here, so I can plot the function g.
Wait, Miss, I have a question.
Ask
So, can we prove that they're not inverses in that same sense?
Yes.
Oh,
Yeah,
okay.
if you had come up with a wrong answer over here and we tried to do this, it wouldn't work. Yeah, good question. Anytime I ever ask you to verify, you're gonna see this word verify. If I ask you to verify that f and g are inverses of each other, it's not a trick question, they are inverses of each other. You remember when I asked you to prove that f was an even function? It was an even function, alright? If I don't know whether or not they're odd or even or neither or whatever, I'm gonna say, what are they, odd, even, or neither? And you gotta answer that question. There's gonna be plenty of test questions on your next quiz. I'm gonna give you f of x equals g of x equals. And the directions are gonna say, are these functions inverses or not? Right, yes or no. And that's it. You don't have to show me any work. Just gotta say yes or no. So you could, try your best to guess throughout the whole thing, or you could learn the material and be able to ace every one of those questions. Alright, so over here, give me some points.
-9, -2.
-9, -2, very good. Are you guys okay with that?
Yeah.
Okay, so -9, 1, 2, oh god, 3, 4, 5, 6, 7, 8, 9, 1, 2. Alright, -9, -2 is there. Whew, that was hard. What?
0, 4, 2.
Okay, I heard -3, 2, and I heard 0, 4. Let's go up to 0, 4. 0, 4. -3, 2. -6, 0. Where's that? That one? Okay. -6, 0. Hey, look. -6, 0 is here, but 0, 6 is there. Would that be logical?
Yes.
That the y-intercept for f would be the x-intercept for g?
Yes.
You sure?
Yes.
Good. Alright. Does that make sense that the x-intercept for f would be the y-intercept for g?
Yes.
Why?